Hello guys, welcome to my YouTube channel MathFitMan. In today's video, we'll be discussing about Taylor polynomials. It was discovered by the English mathematician Brooke Taylor in the year 1715. Okay, but what are Taylor polynomials, you would ask? Well, Taylor polynomials are the representation of non-algebraic functions into infinite polynomials. Let me show you with the help of an example. Here I have the function sin of x on the screen, whose Taylor series needs to be found out. Now, the first step of finding the Taylor series is to equate the y-intercepts of the function and the polynomial that we are going to create. The y-intercept of sin of x is 0, so the constant or the y-intercept of our new polynomial will also be 0, which is okay if I do not write. The next step is to equate the first, second, third, fourth and so on, the derivatives of the function and the new polynomial. Now, the first derivative of sin x is the cosine of x, and the cosine of x at x equals 0, which is this point, is cos 0 or 1. Now, the first term in our polynomial will be the integral of 1, which is nothing but x. We ignore the c because c just moves the polynomial up and down. Now, we have to equate the second derivatives. So, the second derivative of sin x is minus sin x, and minus sin x at x equals 0 is 0. So, in our polynomial 2, the second degree term can be ignored. Let's find the third derivative. The third derivative of sin x is minus cos x, and minus cos x at x equals 0 becomes minus 1. Since we found out the third derivative, we need to find the triple integral of minus 1 as our next term. Now, if you note integration, you will easily find out that the triple integral of minus 1 is negative x cubed upon 6. Negative x cubed upon 6. Alright, but for now, I will cancel this 6 and write it as 3 factorial. You will get to know why I wrote 6 as 3 factorial as we move ahead. Now, let us equate the fourth derivatives. The fourth derivative of sin of x is again sin of x, and at x equals 0, sin 0 becomes 0. So that term can also be ignored in our polynomial. Now, the fifth derivative of sin x is again cos of x, and cos of x at x equals 0 again becomes 1. Now, as we differentiated sin of x 5 times, we will find the fifth integral of 1, which turns out to be x raised to 5 upon 5 factorial. Now, if you know the power rule, this calculation would be easy for you. Okay, let's continue. So, the sixth derivative of sin x is again minus sin x, and at x equals to 0, minus sign of 0 becomes 0 itself, so this term can also be ignored. Now, the second derivative of sin x is again minus cos x, and minus cos x at x equals 0 is minus 1. So, we find the seventh integral of minus 1, which is minus x raised to 7 upon 7 factorial. Wait. Did you notice something? We are approaching the sine wave, and did you see the pattern in the polynomial? Yes, that's why I told you it's not that difficult. Now, let me just follow the pattern and show you the magic. See, it is working very well. So, we actually found out the Taylor polynomial for the sine of x. Obviously, this continues till infinity, but we are on the right path. And knowing this much is sufficient for finding the pattern. Thanks for watching my video. Please like and subscribe. And don't forget, Math with Man will always be fun. See you in the next video.